Welcome to qnawire.
Hello. Here we have to answer a bunch of questions, therefore I summarize the answer first, and now I'm going to walk you through it. So first we have to specify the units of E, and the E can be calculated as force divided by charge. Therefore, its units are either newtons per coulomb, or in the international system of units, it's volts per meter. So the second question is to calculate the value of E. So E can be calculated as k cubed over r squared, and here Q is above zero, therefore, Q is positive, therefore E will be directed from the charge. So E is minimum when R is very high. So when R approaches infinity, E approaches zero, and E reaches its maximum when R is maximum. So it apparently doesn't reach some maximum value, but it increases a lot when we approach the charge. So then we have to calculate the field in the middle between 2 points, 2-point charges, -1 nanocoulomb each, which are located at 2 meters from each other. So therefore, the distance r between the point and each charge equals to L over 2. Therefore, we can apply the superposition rule. The field at the center equals to the sum of fields created by each charge, so it's E1 plus E2. But due to the fact that the first charge is positive, it will create a field which is directed from this charge, and the second charge is negative, so it will create a field which is directed towards this charge. Therefore, we can replace it when projected on x-axis. We get a sum of two electric fields. So which equals to 2 multiplied by k cubed 1 over r squared, because both charges have the same absolute charge, and it equals to the following. So k is 9 power multiplied by 10 power by 9 Newton meter square of Coulomb square. So we multiply it by charge and divide by square distance. So it equals to 18 volts per meter. So then we have to specify, like we have to calculate potential when distance approaches infinity. So when distance is very high, the potential approaches zero because of the formula shown here. So V drops with the growth of R. So and lastly, we have to calculate the potential at the center between 2-point charges. Each is -4.1 microcoulombs, and the distance is 7 millimeters between these two charges. So again, we apply the superposition rule. It's a simple, it's just an algebraic sum of two potentials. So here, both charges are the same, distance is also the same, therefore potentials will be equal. So each potential equal to kq1 over half L. So therefore, the overall potential equals to 4kq1 divided by L. And if we calculate it numerically and take into account the number of decimal places, we get this answer. So it's -2.11 multiplied by 10 power by 7 volts. Here is the answer to this question. Thank you very much for submitting it. I hope I helped you.